Okay, so going off the title alone, you're probably wondering, this is just input. Why does this need its own video on it? And to not waste anybody's time, the answer is simply the fact that we're doing this in Unity, and Unity does not deal with input all that well, which is strange considering this is a game engine. Now, I could go into a summary of how and why that is the case, but it really wouldn't do justice how needlessly complex this whole thing actually is. So with that out of the way, Sonic Rush 3D's input, everybody. Okay, so to start things off, let me bring you back to 2021, where we released the first demo of Sonic Rush 3D. Why bring this demo up? Well, it's because this demo had actually pretty decent controls if you were using an Xbox controller. This sort of leads into my first point of why I said Unity doesn't handle input all that well. You see, the legacy input system, which is the input system that Unity has by default, while it can be used pretty well in terms of coding for it, the problem is that the way it actually registers the button inputs and stuff is very primitive. Each sort of action or input that you can register in the input system via the project settings in Unity can be mapped to what are known as joystick buttons. And these buttons are basically just like numbers, pretty much. The problem with this, however, is that the buttons are not consistent with each controller, like, at all. And what's even funnier is that it's not even consistent between the same controller but on different platforms. I mean, look at this. The other issue that kind of stems with Unity's legacy input system is also the fact that there was no real solution for remapping controls. Okay, so now that I provided the context for the previous version of the game and why the input was bad there, you can now understand that I really wanted to fix this in the new release for Rush 3D, which was supposed to be our big comeback since we hadn't had a demo in, well, 3 years at this point. So those of you who have actually used Unity before probably already know of a feature that probably could have fixed these issues, and that would be the new input system. See, even Unity, the company, realized that the input system for Unity was kind of bad. And so, of course, they needed to find a solution for this themselves, which is what pretty much turned into the new input system. So what does this new system offer? To sum it up, the new input system offers the ability to remap actions for the two buttons, a more consistent button mapping system, multiple input maps that can be swapped at runtime, and a lot of other shit that I can't be bothered to list right now. So with that said, it would probably be a no-brainer to use this system, right? Despite seeming like on the surface that the new input system would be an objectively better solution to the legacy input system, the new input system has its own whole plethora of problems that keep it from even really being viable in the first place. See, when I said a lot of shit, that's also part of the problem, as the new input system can be needlessly complex. To show you what I mean, let's look at actually coding with each input system. The legacy input system is actually fairly simple. After setting up the axes in the project settings, if I want to get whether or not a button is being pressed, I simply call input.getButtonDown and then pass the name of my desired button as the parameter. And for getting the release of the button, or whether or not it's just being held down, I call getButtonUp and getButton respectively, with the input name as a parameter for both as well. And if it's an analog input, I use getAxis instead to get the value of that axis. For the new input system, I first need to create an input actions asset, set up a map, then the actions I want. The actions themselves can also have new parameters that can be added to each of them, which determine how and when they are used. I then have to set up all of the bindings, and those also have some of the same options that the action itself has for some reason. Overall, not too bad to set up the inputs, inputs. Certainly more options than the legacy system, but that's not entirely bad. Here's the problem. First, you have to create a C# class with this, otherwise you won't be able to use it in code. No big deal, we just hit this checkbox here and it's done. Then, in the script we intend to use, we need to create a reference to the input actions asset class and the individual actions with it. Oh, and don't forget to use the necessary namespace to actually be able to use this stuff, or just the namespace itself every time you're using something from it, like you're programming in C++ or something. I don't know, I'm not your dad. Then, on awake, you need to instantiate a new instance of your input actions class, and then we can finally make the equivalent of get button down, or get button up. There's a slight problem here though. See, the defining feature about this input system is that it's based off of C# events rather than booleans of the button's state. So we don't have those functions anymore. Instead, we have to subscribe one of 3 events our action has to the function we want it to activate, those events being started, performed, and cancelled. Those 3 events are actually driven by how you configured the action earlier, with the action setting being how the events are called, and the interactions part being when the events are called. For a simple function on a simple script, this might be fine, but if you were to try and use this in, let's say, a finite state machine, you would need to not only subscribe events on initialization of the state, but also unsubscribe those events when the state is exiting. And since states tend to swap out of each other pretty frequently, you end up having a system where events are subscribing and unsubscribing constantly, which is not good for performance. So you would then need to make a separate input handler script which can handle the inputs and get their states on their own represented Boolean values, which can then be read by the scripts when necessary. So basically making a script that mimics the functionality of the legacy input system. Are you starting to see why I don't like this system all that much? You're basically having to jump through 15 hoops to do the same thing you were able to do before with the legacy input system, give or take a few quality of life changes. And given that Rush 3D actually does use a state machine, I already knew that using this system was going to be a pain. However, there is a third input system that Beats actually introduced us to, Rewired, a third-party input system that doesn't replace the workflow of the legacy system like the new input system does, but instead adds features and functions that make the system more robust. I ultimately decided in favor of letting Beats add this for the simple fact that the API is almost identical to the legacy input system. After a bit of discussion and waiting, Beats finally added Rewired to Rush 3D, and just like that, controller support is no longer complete garbage, and we're done, right? Of course not, because there's still a crucial feature that we need to add in order for us to be done. That feature, of course, being input remapping. Now, this is going to be where things get a little tricky, because no matter which input system you choose, it's not exactly simple to add input remapping to your project. Whenever I started out with this task, trying to do research on how to do this in Rewired was a bit tricky, because there weren't many resources outside of the official documentation that actually talked about using Rewired all that much, let alone anything about input remapping. Another issue I ran into, and this may be partially my fault, is the fact that whenever I did try researching the documentation on how to do this, the thing that I got led to was Rewired's built-in control mapper, which is not only really difficult to incorporate well with our UI, but it's also not very customizable, since the thing I actually needed to look at was not only labeled super similarly to the control mapper, as it's labeled input mapper in the miscellaneous section of the documentation, but also was not even showing up whenever I tried searching it. I never actually saw it and just assumed that the control mapper was the only way to remap controls using Rewired, or at the very least, the only intended way. It also didn't help that when I looked into how to save these inputs, the only thing I got after searching for that was a script that could save player controls to player prefs. I could go into a whole rant about why this is really bad, but that's for another video. Plus, even Rewired says this is a bad idea, so you probably shouldn't do this. Searching about this afterwards led me to finding out about another Rewired built-in script that saves input maps to JSON instead, but that's in one of the later versions of Rewired for a version of Unity we aren't using. I would make one myself, but the main issue is I don't actually know what data needs to be saved in Rewired, and the documentation doesn't really help with that. So unless there's something I'm missing still, I couldn't do it the intended way, so I kinda had to make a hacky solution for input remapping in this game. Have you ever noticed how the parameter to check which action Rewired needs to look for is a string value? Well, I did, and I had an idea to exploit that fact to get around our limitations. Ladies and gentlemen, allow me to show you you how input remapping for the release of the game actually works. On this screen, each of these buttons are assigned to a specific action to be remapped. Once the button is pressed, a window will pop up prompting you to press a button on your controller you want to assign to the action. Then, whenever it receives the input, the script will then check to see the input pressed and the name of the rewired action that pressed it, ignoring the UI bindings of course, since those are unchanging. Once it's got the name, it will assign that name to the associated action in the user settings, and that's it. There is one problem with it, however. Some of the inputs which were originally designed with the standard controller layout were assigned to keyboard keys, but that also meant that it was only possible to remap 8 keyboard keys in total. This was a problem I knew going into it, and it wouldn't really be something I was able to address until post-launch, because the only solution for it would be separate inputs assigned to every keyboard key I can think of people using. I did actually get around to doing this post-launch, but we never actually released the update yet. Now you think we might be done here, but there's actually still one more thing to talk about because it led to one of my most embarrassing oversights of all time. So anyway, after getting input remapping to work, I got an idea on how I could improve the hint rings to show you which button you needed to press for whatever the hint rings were showing you how to do. And I just so happened to have stumbled across a video that showed me how to parse text, primarily for use in a visual novel type game, to get it to do whatever I wanted when special formatting is in play. So as soon as I got around to doing that, I immediately made a system that would parse any hint ring text before it was displayed, and then convert whatever action was in angled brackets to the name of the desired button as assigned by the user settings. For anyone curious on how the parsing works, it's not that complicated. Just iterate through text by each individual character to be added to the final string, then every time there's a special formatting character, set a flag to ignore that character for that iteration, and another flag to start adding the following characters to a separate string for processing later. Once it reaches what is set to be the ending formatting character in the iterations, it can then ignore that character as well, which will finalize the string needed for processing, then process that and add it to the string to be displayed. You can then continue with the loop as normal. The processing for the input text is even simpler. First, make a string for the Xbox button name, PlayStation button name, and Nintendo Switch button name, then make a switch statement to process the parsed button name and set each of the button name variables accordingly. Finally, do one last check to see which controller it is and then return the correct name. Just like that, the names are displaying properly when we set up the hint rings, and it's stupid easy to work with in the editor too. It would have pretty much been done from there, but temzy decided to take things a step further, so he went back and edited my name processor function to instead have this strange looking sprite index text. I had no idea this was a feature at the time, but apparently TextMesh Pro can actually display sprites in the middle of a text string provided you set up a proper material for it, which temzy did with his own button sprites, which, I'll be honest, look damn good. And with that, we can now roll out the build for Sage and everything is fine now, right? Man, you have been on a losing streak today. It's here where I have to mention how important it is to make sure you not only have a decent sized team for playtesting, but also have a diverse one, something that I will be getting into much more in depth once I inevitably talk about ring racers. The reason I bring this up is because throughout all of our tests, the input display was working great for each controller. The problem, however, was that it was only working for each controller. See, none of our playtesters played on keyboard at all, so nobody noticed until after the demo had already been launched at Sage that I never put any checks for if there wasn't a controller during the button name processing. This ended up being a big problem because this ended up breaking the hint ring dialog entirely, meaning that it would only display the default text in the hint ring dialog. This normally wouldn't be an issue since stuff like this would normally be blank. However, temzy was using the default text to test how well the sprite icons would actually work in-game, and the message that he decided to write? I'm not gonna sugarcoat it, he made a goddamn kill yourself screen. Yeah, to say this put me into a panic would be an understatement. I think my hair actually thinned out because of this week in particular. Thankfully, there's not really much to say in terms of fixing it. Beats just quickly added in this thing in the button name corrector, and temzy rushed to remove his test dialog, both of which actually did come out in a brief bug fix that came out like 2 days after Sage. So you won't be able to get this bug yourself anymore if you didn't have this version. Alright, now we're all good, right? Nah, I'm just fucking with you, we're done now. Oh yeah, one last thing. If you guys press 1 on the top of your keyboard, you can actually enter a mirror mode.